In this presentation, we're going to look at a one-way ANCOVA. ANCOVA stands for Analysis of Covariance, and it's one way because we're only going to be looking at one dependent variable, which in this example is going to be jump height. So we can think of the ANCOVA as an extension of the one-way ANOVA, which is going to be differentiated by the fact that we're going to incorporate a covariate here. So a covariate could be, for example, you look at the difference between athletes controlling for height or controlling for mass or controlling for playing experience. So here's our one-way ANOVA. We look at difference in means across these three teams in terms of jump height. But what we want to do now is see which team can jump the highest following training when we control for baseline scores. So this is what makes it an ANCOVA, whereby we are now looking at a difference in adjusted means. So this ANCOVA then has that benefit of allowing us to statistically control for some third variable, this confounding variable that we think will affect our results. And I'll encourage you to look at these two papers, which describes how this is the best method for looking at changes following some training intervention. So let's look at our data in SPSS now then. So I've just put our three groups in here. You can see we've got a control group, a group that did intervention A and a group that did intervention B. So we're going to data view and click that. So here's our three groups. We just go to analyze, we go compare general linear model. It's a univariate. There's only one dependent variable, and that is how high they jumped following the training intervention. But of course, our covariate is the height that they started the intervention at. That's what we want to control for, a confounding variable. And of course, the fixed factor is the group because we're comparing across groups. Because we've got three groups, we are going to do some postdoc analysis, and we'll just do that using Bonferroni. Continue, and we'll get some descriptive statistics and look at the variance across groups, make sure that they're all similar. And we'll just leave the significance level at the conventional alpha of 0.05. Press OK. So here's our output. So here we have equal variance across groups, like the value is greater than 0.05. And when we look down here, we do see that there is a significant difference across groups. Of course, there were three, so we have to look at our postdoc analysis to reveal where that difference is. So when we come down here, we can see across these pairwise comparisons that control group was statistically significantly different from intervention A and B. And here when we read across, we can see that A was different from control but not B, and then it will be likewise down here for intervention B. So given the means, we can say that both interventions A and B produced a significantly greater jump height than a control intervention, although there was no difference between those interventions.